Hi everyone, in this video I want to talk about rewriting and solving with rational exponents. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. If you had to pick, which language would you choose to learn? So on the math section under Algebra 2, you would see questions related to rational functions, but that section also can include questions about exponents, including rational exponents like we'll talk about here, and radicals. Radicals with all different roots. So in the first one, it's mentioning something about radical form. Let's talk about the two different forms that you have with problems like this. So you can see radical form, and then exponential, I should say rational exponent form. So radical form looks like this. It would be like n x and then the whole thing to the mth power. If I put that in rational exponent form, it would be x to the m over n. And the reason for that is, like, if you take the square root of x, that, remember, there's like a sneaky little 2 right there if it's square root. That would just be x to the 1/2. If you took the cube root of x, it would be x to the 1/3. And so on. Fourth root of x, that would be x to the 1/4. So I'm going to take a number where you can actually take the square root and cube root of it. So square root of 64 is 8, because 8 squared is 64. The cube root of 64, well, you have to think of what to the third power is 64. So, like, what to the third power is 64? And the answer to that is 4. So the cube root of the square root of 64 is 8. The cube root of 64 is 4. And something that you could take the fourth root of would be, say, 81. Fourth root of 81 is 3, because 3 to the fourth power, that's 3 times 3 is 9, times 3 is 27, times 3 is 81. So what the questions here are asking relate to all of this, back knowledge of rational exponents. If you had x to the 7/6 power, that would be like this m and n business. So m would be 7 and 6. And so I'm going to use this right here to help me figure that out. But if I don't have these formulas in front of me, I can just think of this as x to the 1/6, but then to the 7th power. And I remember, like, this pattern here tells me that this is the 6th root of x, this section right here. And then I would just take that and raise it to the 7th power. I could also have that, but with a little 7 on the inside. Either way, the 7 would be the top number, the 6 would be the bottom number. And in this next question, it asks you to actually use this knowledge to solve. So on the ACT, it's very vague, and they say for the standard that you need to apply rational exponent properties to answer questions. So, like, this one has a rational exponent, but you're actually solving this time. So the only way to get rid of the 1/3 is actually by multiplying by 3/1, because this x you're trying to get by itself, you need an exponent of 1 in order to isolate that. So whatever I do to one side, I must do to the other. So see, that's like a 3/1, so that basically cancels, and you have 81 equals x minus 23. If I add 23 on both sides, I'll get 104 as my answer. So try a few practice problems here. Notice that this first one is very similar to my first one, but it has you going from radical form, the root, to exponential form. And then in the second question, it would be something very similar. You would have to, use the reciprocal, but it's a slightly different setup of an equation. Try those. You can pause the video, see what the answers are in just a second. Okay, so in the first one, you would just take the 10p and raise it to the 1/6, and then 81 is what you would get for p or v in this case, v for that second question. And a quote to leave you with some inspiration: you only live once, but if you do it right, once is enough. It's a great quote by Mae West. I hope this video helped you in some way, and if you'd like to leave an answer to the fun question in the comments, that would be great. Feel free to subscribe if you would like to keep up with more videos. Thank you.